This is a standard conservation of energy problem. So we have an object that's on the ground and it gets launched with some particular velocity v, and it's moving straight up. It reaches a maximum height, and that's what we're interested in finding. We want to know what that maximum height is. So we're looking for h. So what are our givens in this question? We have an initial velocity equal to v, and we know the acceleration due to gravity is equal to g, and it doesn't give us a mass, so we'll leave mass out for now, and I'll show you a strategy on how to deal with questions that don't have masses given. We don't actually need the mass, and we should already realize that from our work in when we're dealing with dynamics and kinematics, because things accelerate. Things, when they accelerate downwards, their velocity and their acceleration are not dependent on mass. So it doesn't matter what we fire up with velocity v, all the objects should reach the same height. So this is a conservation of energy problem. So we're gonna find delta H using conservation of energy. So the way I like to do these problems is I look at the total energy at one position. So the initial position will be here at the bottom, and then our second position will be at the top. So the total energy at the bottom equals the total energy at the top. And then I break this up into two energies. So at the bottom, I have kinetic energy, so that's Ek. And because the ground is my reference position, I don't have any potential energy. So that's ET1 is equal to Ek. And I'll say Ek1 to differentiate it from any kinetic energy that's up here. Position 2, because this thing is at its maximum height, it has come to a stop momentarily before it starts falling back down. So therefore its Ek, its kinetic energy, is 0. So it only has potential energy, specifically potential gravitational energy. So Ek1 is equal to half of m vi squared, which is equal to mg delta h. Now you can see why mass doesn't matter, because algebraically these will cross out. And then I'm solving for delta h, so I'll bring the g over. And I'll just rewrite this so it's a little cleaner. And this is our answer. So if we were given numbers, let's say that we were giving 10 meters per second, and that's what our velocity will be in meters per second. And the reason why it has to be in meters per second is because little g here is in meters per second squared. And energy is, the units of energy are in joules, and 1 joule is equal to a newton times a meter, which is also equal to, a newton is equal to a kilogram meter per second squared times a meter. So all of these units involve meters, so it's a good idea to convert everything to meters and seconds. And so if you are given values like 10 here, then you could easily replace 10 squared divided by 2 times 9.8, and that would get you the maximum height of the